Another problem. We will see another problems. So something like say 2 kilonewton per meter and 20 kilonewtons, and it's a 10 and it's a 12 meters and it's a 12 meters and it's a 4 meters. Okay, that is the problem. That is the problem. Okay, that's it. That's it. See how many number of integrals, what is the indeterminacy. So check it. It's a 2 1 1, it's a 4 minus 2 2. We exclude horizontal loading, so without horizontal loading 3 plus 1 1 5, it's a 3. 5 minus 3 is 2. If it is exclude horizontal indeterminacy also, 3 1 1 5 minus 3 2. No problem for this. Okay, so it has a 2 indeterminacy. How we will solve? So we already solved. It's just proper cantilever. We already solved proper cantilever. We just increase one indeterminacy extra. One indeterminacy extra. How we can solve? By using the force method, using 3 moment method. Okay, so start with we already know that's MA L1 2 MB L1 plus L2 MC L2 plus, you can take its plus 6A1 X1 divided by L1 6A2 X2 divided by L2 is equal to 0. You can take plus plus, otherwise you can take is equal to. I already explained what is the difference. Some textbooks write like this, some textbooks prefer another. So no problem at all, just changing one negative sign. So if you're using this sign, this type of equation, you will get MA and MB or MC. Negative sign means hogging, positive sign sagging. Otherwise if you use is equal to 6A plus 6A something, MA and MB, if you get positive, that is the hogging, negative sagging. Okay, so prefer just do 1 or 2 problems, then you will feel which one is comfort, take it is. Okay, so say it is A B C. Write it. If you see, we have only 2 spans, we get only one equation. We will get only one equation. But if you see, they has moment, bending moment at A is there, bending moment at B is also there, bending moment at C is 0 because it's a outer edges, hinge joint, not a hinge joint, it's a hinge support at edge. So MC is 0, we already know MC is 0. MA and MB are not equal to 0. So MA is a fixed support, MB is, B has a hinge support, but it is an intermediate giant. Intermediate giant behave as a fixed giant. Understood? I already explained it. It will rotate. Okay, so that's it. So I have one simple doubt. So do you have get any doubt regarding whenever you see any continuous beams or anything, it will write like this. It will write like this only. It can't write whenever you see it, they are preferred to use roller supports, not a hinge supports. We call it as a roller. Every time they use take a roller supports, not a hinge supports. What is the difference? Why? Do you have any doubts? So because if see it is, if the temperatural changes are happened, temperature changes are happened, if roller support is easily expanded. Are understood? Temperature changes are happened, roller supports easily expand, like easily expand it. Otherwise, if you provide a hinge, there is no horizontal. So if it is a horizontal restraint, it can't expand. Then it temperatural stresses are arising. Temperatural stresses are arising. So that's why indirect loading is coming. Indirect loading is coming. Are understood? So that is the problem. So that's why every time using roller supports. So one end, if you take a simply supported beam also, one end is compulsory roller. Understood? If it is not a roller, what will happen? So if temperature stress is happening, it will expand it. If it can't expand, temperature stresses will arise. Understood? So that is one of the student asking. Okay. No need to explain. No need for this. No need for this today's topic. We will solve the problem. Okay. See it is. We will get only one equation, but we have unknowns of two. Two unknowns are there, but we will get only one equation. Okay. Now we will try to write down the equation. Okay. First we will go to the simply supported. Take as everything is simply supported. Write down the bending moment diagrams. Take it simply supported. Write down. So first one is like this now. This is 4 and this is 8. What is the value? PAB by L. You know it, na? So PAB by L. What is that value? Take it. P is 20. Understood? 24, 8. Answer divided by L is 12. So 53.33. So this is 53.33 kilonewton meter. Okay. So that is the bending moment. So second one is simply supported. So that is parabolic. What is that value? WL square by 8. What is that value? W is 2, L square is 100 divided by 8. We'll get 25. It's a 25. Okay, it's a 25. Understood? That's it. If you're using. So what is the centroidal distance? So for the second span, it is exactly half. We know it. What is it? It is a 5 meters. For the first triangle, where is the centroidal distance? I already explained the proof regarding this value. So otherwise, if you take in centroidal distance, take it as a like. So take from this support. So x distance is area of this first, and centroidal is this. So how can you calculate? So 53.33 centroidal distance. So multiply with 4, multiply with half. That is the area. Centroidal distance is 1/3 of 4. 1/3 of 4. So next this area. What is that area? 53.33. So again 8. So again 8 of, that is the area, and central distance is this na? This. So sorry, first one is not 1/3. It's not 1/3. It's a 2/3. It is the central distance na? 2/3. 2/3 of 4. So second one is, so what is the distance is? Distance is 1/3 of 8. Understood? So 4 plus 1/3 of 8. That is the central distance na? Divided by total area. You will get central distance. Otherwise, we already solved one. We already solved one problem regarding this. Where we solve it? We solved one problem regarding this. Where it is? I think in fixed beams. Where we solved something. So this is, we solved it, no? We solved it. Are you understood? So we solve it, same thing. So centroidal distance is what? Centroidal distance is getting exactly, we get the proof is L plus A by 3. Are understood? So if you remember the formula, okay, no problem. If you don't remember the formula, just do it. Just do it. So what is the distance? Centroidal distance is L plus A. A is 4 by 3. What is that value? 16 divided by 3. 5.33 meters. If you didn't get it, okay, do the problem. No problem at all. So don't remember any formulas. Just do it, do it, do it. Later you have the ability to remember it. Not try to remember. Just doing or doing. Later you can easily remember. Okay, that is the our idea, not idea. That is the way to get the information, not to mug up. Okay, doing. Then it automatically it will come into your mouth. Okay, or your mind. So centroidal distance is exactly, it's a 5.33. Maybe exactly here something. Okay, 5.33. This is the centroidal point. Not a point. It will come to its center something. Okay, so that's one thing. So we got it. So we will do formula. So okay, MA L1 is what? L1 is 12. 2 MB L1 plus L2 is 10. MC is a 10 plus 6 area. So what is the area of the fence first? What is the area? First area is same. We got it now. 53.33. 4 of, that is one area, plus 53.338 1 by 2. So that is the second. So total area. Otherwise you can directly write it. So bottom of ABH. So of ABH. So okay. Otherwise this is 53.33. So 12 of. No need to write two parts. Okay. So divide by L. L is 12 plus second one is 6. Area is, so automatically x1 is there now, multiply with, so distance of 5.33. okay, of area into x1 divided by L1. Second one is 2 by third of 25 into 10, that is area. Central distance from C earth divided by, so area C, length is 10 is equal to 0. If you using like this, if you get a negative value, that is means hogging movement. Okay, we already know MC is 0. Then you just strike out MC. Okay, or get it? You get strike out the MC. So what is that value? What is that you will get? What the equation you will get? You will get the equation like, MA plus MB into 3.67 is equal to 112.73. That is the first equation. MA in MB. Okay, so that is the first equation. So we have two unknowns. So MA and MB unknowns, but we get only one equation. How we will get another equation? Is there any chance? No chance. How we will use three moments method again? So that's why some scientist, not a scientist, some engineer said that just take an expandable span. You just imagine an expandable span which has AA support is there. There is no loading at all. Just imaginable span. Okay, so take it imaginable span. Okay, so Try to apply three moments method for that span. What is that span? A, B. A and B. Try to apply. Okay. So this is the first span. Later span is A, B, C. You can use it. Yesterday I said, na? So if we have four supports, you will use first equation for this three. Later use this three. So you will get two equations and two unknowns center. Like this. Okay. So how we will apply? See it is now. Now you can see it is. So we will apply three moments method for the span of A dash A B. You already know what is no. M A dash is 0. There is no nothing. There is no supports. There is no anything. And also loading also 0. L also 0. L1. So L1 means this is now this is L1. This is L2. Understood? Everything is 0, but we can take an imaginary, just observe it. So okay, so I will write like span. So this is a span. Okay, this is A dash A and B. It is a loading. Okay, so 20. So this is L1, this is L2. This is 4, this is 8. Okay, this is 4, that is 8. So what is the bending moments? Write down. For span is 0. So second span is, we already know it. This is a 53.3. This is 4. This is 8. Everything is known. So apply for this. Apply this three moment for this span. So okay. MA dash. L1 is 0. No need. So 2. Now it is MA. 0 plus second span is 12. MB. Now it is MB. Span of 12. Okay, span of 12 plus 6 A1 8 x1 divided by L1. So no need, because area is 0. Bending moment, there is no bending moment at all. Understood? There is no bending moment at all. Second thing, 6 area, we already write it. We already write the area where it is. So 53.12 into half. So and also centroidal distance is 5.33. From this span is 5.33. For this point, from this point is 5.33. But one thing you have to remember it. So for the second span, we have to take a centroidal distance from where? From this point. Understood? For the first span, we'll get centroidal distance for this point, from this point. For the second span, we have to write centroidal distance from edge point. So okay, A dash and B, not A. Okay, so now it is not 5.33. That's why I take up this problem. Okay, it's a 12 minus 5.33. Understood? So that's it. Divided by L1 is L2 is 12. So MA dash is 0. MA dash is 0. This problem is 0. Okay. So and also observe it. This is like this is equal to 0. For the previous students, I said using this is equal to. Maintain is equal to now. For your previous students, that's why they will get like this equation. No need. Okay, you will get like this. So that's it. That's it. So now what is the equation? Is equal to 0. What is the equation we will get? Same again in terms of and MA and MB. What is that equation? See, 2MA plus MB plus 88.93 is equal to 0. You will get second equation. Okay, this is the first equation. Okay, this is the first equation. That's the first equation. So this is the first equation, second equation. So two equations, two unknowns. You can solve it now. You can solve it. This is the one equation. Second equation is MA plus 3.67 MB plus 112.73 is equal to 0. That is the two equations, two unknowns. You can solve. You will write one in terms of the another. So if you see it is, if you take a second equation, 2mb is equal to 88.93 minus mb. Okay, so otherwise you will write mb. Otherwise you will write mb. It is simple, I think. So 2ma plus 88.93 is equal to the mb but negative sign. Okay, so try to put into this equation. You will get ma and mb. Later you will get ma and mb. That's it now. Very simple. 6th class, I think. 6th, 7th introduced in calculus. Okay, so what is the values you will get? MB is 21.53 negative. MA is 33.71 negative. You will get like this. So negative means it's a hogging. So most of the chances you will get the hogging moments. Whenever the couple is acting, that's only it has some problem. Otherwise everything you will get almost hogging. Whenever you will apply the hogging, I said na, whenever you will apply the couple moment, then only it will come like this. So it is a hogging moment, but it is a sagging moment. Understood? Couple, whenever they acting the couple, it will get positive sign. Remaining everything almost not, so not exactly but almost. Okay, that's it. If you got MA and MB, then the problem is ending, then the problem is over. So okay, understood? Problem is almost 90% is over. 90% is over. So then you have to find out the shear forces. So understood? You see it is. So what is that? This is a 20, this is 2, this is 10, this is 8, this is 4. So MB is what? MB is hogging 33.71. MB also hogging. Hogging means it will come like this, for this span 21.53. What is the bending moment diagram? You can directly write it. No need to find out every span. How can? We already know it. So you can directly write like this. You can directly maintain it. This is 53.53. This is what? This is what we get. This is 25, no? That is 25. So that is 25. Simply supported. What is the fixed end moments? These are all plus moments. That is a sagging moment. These are all sagging moments. Fixed end moments are hogging moments. What are the fixed end moments? So it is a 33.71 hogging moment. B is 20. B is 21. So 21 means exactly maybe. Okay, 21. It is a 25, na? So that's 21. It's a 21.53. This is 0. So you will directly add it. So this is a fixed end moments. This is opposite to the previous. So that is a hogging. This is a sagging moment. So this is a negative. So positive negative will collapse it. Positive negative is collapse it. Where it is collapse it. Remaining is the bending moment. Diagram. Understood? Remaining is the bending moment diagram. So that's it. This value is 21.3. Otherwise, if you try to draw simple for section, you will get like this. No problem. You will get like this. See it is. So you will get like this. How can you get? It's a 21.53 na hogging moment. This is 21. So this is 33 hogging moment. So this is 0. If you try to draw a curve, it will come to like this. Sorry. It will come to like this, and this it will come like this. Understood? Just see it is. Just see, observe it. This is the remaining value. The remaining value is positive, positive, positive. What is that exact value of bending moment at this location? This is the value. Exactly, this is represent this value. No need to write like this. Two types. Both are equal. Both are equal. If you try to directly, it's a simple. You can directly write it. Positive, negative, collapse it. Remaining value is the bending moment. Otherwise, if you take a section by section, you will get it without finding the reactions. Understood? Without finding the reaction, you will get the shape. You can't find out the exact value of what is the exact value. If you want to find out the exact value, you want to find out the shear force reactions and later get it. Okay, so that's it. This is the value of this value. What is that value? That is value is this value. That's the value of this. This both are equal, same thing. Okay, and observe it. Both are equal. These are the equals. You will represent anything. 33.73. This is a 21.53. Negative, negative, negative. This is a positive, positive, positive. Okay, understood? So now try to draw shear force diagram. So first you have to find out the shear force values. So to find out the shear force, you will get easily. This is RB. This is RA. See, this is RA. This is RB. This is RC. Okay, shear force. How we will get shear force? So directly take into the account of MA equal to 0, FY equal to 0. Use it. You will get it. But it is easier to draw. It is easier to find out the shear forces with respect to the free body diagrams. If you observe it, you will write the free body diagram. So I will write the free body diagram of the BC. It's okay. Or B. If you write it, already shown. How can you draw free body diagram? If you see it is. So this is the free body of BC. So some reaction is there, RC. And also what is the moment at B? Moment at B is hogging moment of 21.53. Are understood? So it is the 21.53 hogging moment and some reaction is there. We don't know. RB1. RB1. I call it as because I said that. So this reaction is only balances the BC span. So, but B has a support which produces the reaction which is support BC span and also BA span also. We already explained last class na? So we will see it. So what is that value? This 2 kilonewton per meter. Strength is 20 na? So take a moment at this place B. Moment at place B is 0. Moment, not a bending moment. RC into 10 minus 2 into 10 force is a 5. So now also bending moment is there. 21.53 is equal to 0. Understood? So what is the value of RC? 20 into 500. 100 minus 21.53 is what? 78.47. Also divided by 10. 7.847. 7.847. So that's it. RC is 7.847 kilonewtons. If RC is known, RB1 is what? Total load is 20. So 7 goes to RC. Remaining was 20 minus answer. It will 12.153. So RB1 is got. Understood? So now we will write second span of second span. So this is A. This is B. RB2. B has a moment of hogging moment. Understood? Hogging moment. It has 21.53. You see it? So if you take a B joint is also equilibrium. B joint is in also equilibrium. It will come like this. It will come like this. Joint is in also equilibrium. If you write a B joint, it is in equilibrium. Okay, but it's a hogging moment. But B has an hogging moment of 21.53. Last class I explained it. No need to this. Okay, so this is a 20. This is a 4. This is 8, and A has a moment of 33.71. It is also hogging moment. 33.73, and a reaction of RA. That's it. That is a free body. Free body means itself is into a static equilibrium. Okay, you can write it itself into the equilibrium position. Okay, so that's it, you can write it. See, it is take the same thing, rb2, same moment at position is 0, moment, not a bending moment, moment at everywhere is 0. rb2 multiply with 12, so opposite 21.53, see it is 21.3 opposite direction. So and next opposite 20 into 4, okay, 20 into 4 plus 33.73 is equal to 0. Those are the moments. So what is rb2? So what is rb2? So 80 plus 21.53 minus 33.73, answer divided by 12, it's a 5.65. Understood? 5.65 kilonewtons. Sir, these are not equal, these are not equal exactly. So at the support of B, reaction is produced. Some reaction is balanced BC, some reaction is balanced BA. That is a 7.84 C, 12.153 that balances the BC, 5.65 balances the BA. But what is the reaction at B? Both are combined. What is the reaction at B now? So if you take RB is 5.65 plus 12.53. 5.65 plus 12.53. So combined produces at B reaction. Okay, 12.53. So 18.88. So and also what is RC? RC is 7.84. So what is RA? So now what is RA? What is the reaction at total vertical forces are 20. So 5.65 goes to RB2. So remaining is what? 20 minus 5.65 is a 14.35 kilonewtons. That's it. You got all indeterminacies or all reactions. Now you can draw shear force diagram. So okay, it's very easy to draw shear force diagram. So see, it is RC is 7.487. Okay, so later RB1 is what? 12.153, but it has a uniformly distributed load. Are understood? It has a uniformly distributed load, so it will come to like, so RB is 12.153, 12.513. So uniformly distributed load, so it will goes to decreasing because RC is upwards, uniformly distributed load is downwards. It going on decreasing for every location and reaches to 12.153. So how can it reach? Okay, it reaches, it's a 12.153, it's a 7.417. But RB2 is second. Now you would draw the shear force diagram for span BA. So at RB2 is what? 5.65 again. So it's upwards shear. If it is upwards, we have to draw downwards. Okay. So what is that value? That is, what is that value? 5.65. 5.65. So now it is a 5.65 at RB2. It will come to this position. There is no shear force at all. Only 20 at this location. So okay. So it will come to like this. And 20, exactly 20 will come opposite direction. So automatically suddenly will increase. Suddenly will increase like this. How much it is? 20 minus 5.65. It's a 14 point. So 14 now. So you will go reached. This is 14.35. So there is no extra shear force and will come to RB. It's a 14.35. Understood? That's the shear force diagram. So now you observe it. What is the shear force at B? What is the shear force at B or reaction at B? So combinedly it's a 18.8. Observe it. It will come at this location of A. This is the location of B. This is the location of C. So exactly RB has a combinedly it has a 12.53 and 5.6. It is acting as a point load. It feels as a point load. The load is acting at B is 18.8. Are understood? 18.8. So see, it's a 12.153. This is a 5.653. Same thing if you observe it at this location of the point load acting, it has a 20. So the shear force at exact that location is come to 20. The total club. See, it's a 14.35. It's a 5.65. So exact same couple acting also. If it's anything couple acting somewhere 100, at that location bending moment compulsory positive negative combine club it together will come gives as 100. Okay, understood? That's it. This is the shear force. Negative, negative, positive, positive. You will mention signs or not? No problem at all. We record what is the maximum, what is the minimum. So okay, that's the shear force diagram. You can draw it very easily, comfortably. Okay, so basing on shear forces, based on the shear force, you will find it. Okay, so that's it. Shear force, and this is the bending moment representation. And you can write, you can draw, you can draw, you can draw. What is that? Deflection diagram also. Deflection diagram. What is the deflection diagram? So I will draw. Deflection is what? Deflection is deflection profile. See, it is deflection profile means what is? See, it has two point of curvatures are there. One is point of curvature, second point, third point, 3 point of curvatures are there. Point of contraflexures. So point of contraflexures. Curvature it changes. Point of contraflexures. 3 point of contraflexures are there. If you are a designer, you have to find out which distance, what is the distance between these two. You can directly find out where is the bending moment going to be 0. From this location, where is the bending moment going to be 0. If you find it, okay. So otherwise, no need. Just to draw, just like a free body type, freely draw. No need to find out the distances. You can draw like, how can it draw and changes and change the curvature now, and the change the curvature now, and will again change the curvature at this location and will reach us. Okay, and will reach us, and it will reach us like this. Maybe it has slope. I understood B has some movement now. So B has some movement. It will some rotate like this, or maybe it rotate like this. We don't know. If you know the deflection, if you know that rotation of the section of B, you have to maintain that deflection. But now we don't know. So later slope, deflection, moment distribution, we have to find out what is the deflection at this location B. See this, it has a B, so it may be rotate. It may be rotate like this, or it may be rotate like this. We don't know, but I will most probably I have a chance because it has a 20 na? It has a 2 uniformly distributed loaded. Mostly it will maintain the slope here, and it will come to decrease, and it will come to decrease and change this deflection, and will go, it will maintain slope. Okay, that is the deflection profile. So deflection profile we can draw based on the point of curvatures. Are understood? Point of curvatures and the rotations. At the B, at A has rotation is 0, at B has rotation. Based on that, you can draw curvature diagram also. That is a curvature diagram. That is a curvature also. Curvature is what? 1 by R. Curvature is 1 by R. Based on the deflection only we will get curvature. Okay, based on the curvatures, deflections, everything is interrelated. So that is the complete picture of problem. Are understood? This is the complete picture of the problem. So if any problem I given to analyze the section, analyze the beam, you have to find out the moments, reactions, shear force diagram, bending moment diagram. Later if you draw a curvature diagram also based on the point of contraflexures, that is the complete. That is the completion. How can you draw? I will show you. Okay, understood? That is the story. That is the story of one problem. So now I will solve another problem, which is very easy, very easy, very easy. Just see it is. Just see it is. Tomorrow I will explain another system. Okay. This is the problem. This is the problem. Okay, understood? So I will give 8 kilonewton per meter. 8 kilonewton per meter. Okay. So distance is 8. Once again 8. Okay. 8. Okay. Very easy. I will provide easy problem. So how can you solve it? It is A, this is B, this is C. How can you solve this problem? If you see the problem, A is a fixed support. C is a fixed support, MA is there, MC is there, and B is a hinge support, but intermediate support. It is a intermediate support. Intermediate support act as a fixed joint. So once again, how many times I said intermediate support. Intermediate support act as a fixed joint. It will rotate it. It rotated, but it maintain uniformity between those two spans. Okay, it maintain uniformity. So it's act as a fixed joint. Fixed giant. Okay, so B also has moment. So three unknowns are there. Are understood? Three unknowns are there. So three unknowns, but we have only one equation. So what is that equation? We have only one equation. So I will directly write it, no problem. So that is the 1, that is the 2. What is that value? What is that value? This value is WL square by 8. WL square by 8. 64. That's it. 64. This is also 64. This is 8. This is 8. Central distance from this location is 4. This location is 4. So we will get equation like MA into 8, 2MB into 16, MC is equal to 8 plus 6. Area is 2/3 of 64 into 8. Okay, area, central distance is 4 divided by L1 is 8. So same thing again will come 2/3 of 64 into 8 into 4 divided by 8 is equal to 0. That is the one equation. So one equation, we have only one equation, but unknowns are three unknowns. Three unknowns, na? Three unknowns, we will have only one equation. How we will solve? So now you can solve this problem like what we did previous problem. Expand it. Maintain A dash. Now another span is A dash AB. You will get another equation. Another equation in terms of A and B. A dash is 0, na? MA dash is 0. So you will get another equation A dash and C. Another equation in terms of MA and MB. So second equation. And same time you will expand this. You will expand. You call it as a C dash. So now you will apply the BCC dash. BCC dash. What you will get? You will get an equation in terms of MB and MC. So now we have three equations, three unknowns. You can solve it. Can you solve it? So we will solve it. So I will try to solve some problem. Later I will left for you. Okay. So take it. So what is that equation? It will come. So this equation will come like 8MA plus 32MB plus 8MC is equal to 2048 plus is equal to 0. That is the first equation. Next, A dash AB. We use it. So no need to draw. We know it already. Okay. This is 64. This is 8. And it's a 4. Okay. So see it is M dash A plus 0. 2MA plus 8. Okay. 8. 8 plus 0. Okay. So MB is 8 plus 6. So this value is 0. 6 something area is 0 plus 6. Same thing. 2/3 of 64, 8, 4 divided by 8 equal to 0. That is one equation. Second equation you will get. You will get it. You will get it. What is that? What is that equation? Second equation is 8MB plus 16MA. Okay. 16MA is equal to 1224. If you apply the same for BCC dash, what you will get? 8MC. C is in middle, na? C is in middle means you will get. So C is in middle, you will get it 16MC 8MB is equal to 2024. Same problem. I make it easy. I make it easy. So without knowing this, you will easily set that MA is equal to MC. By looking into the problem, MA is equal to MC because it's symmetrical. Symmetrical. MA is equal to MC. But looking based on the these two equations also, you will feel that MA is equal to MC. You will make it. You will make it. Okay. MA is equal to MC. So are you understood? MA is equal to MC. Directly solve it. Solve these three equations. See, it is 8MA plus 32MB plus 8MC. Sorry, these are the all is equal to 0. Is equal to 0. Okay. So is equal to the plus 2048 is equal to 0. MA is equal to MB. See, MA is equal to MC na. So make it into the 2. 8MC. So what will come? It will come like 16MC plus 32MB is plus 2048 is equal to 0. Same thing, MBMC, we already know 16MC plus 8MB plus 10024 is equal to 0. These are the two equations. Write down, solve, and what we will get. What you will get. That is the important. That is my observation. That is my intention. What is that? What is that value? Finally, what you will get? You will get like MA is 61.4 kilonewton meter. That is equal to MC. MB is so 23.9 kilonewton meter. Maybe the values are right or wrong. I don't know. Negative you will get. That means hogging moment. So check it once. Check it once. Okay. So if you try down the bending moment diagram, if you try to write down the bending moment diagram, write down the bending moment diagram. This B, it will come to okay. Okay, what is that value? This is the value of 64. We already know it. What is the fixed end moments? Fixed end moments MA is 64. 61. What is that value? This is 64. Maybe the values are maybe wrong or right. I don't know. I just took the problem some random. So 61 is the bending moment diagram. Almost it comes to 61. 61 positive. At center 23. So write it like, are understood? That's it. Total this goes to elimination. These are all elimination. It's called elimination. So what is that? Negative. What is the positive value? This is a very small portion positive value. Otherwise, if you try to draw bending moment diagram with respect to find out the sections, how will look like? Just based on see, it is look like these three are okay. These three are okay. Otherwise, I will draw like these three are okay. How will it shape? How will you will get? How we will get is very small upper portion. Okay. It's like this shape you will get. So this is positive, negative. Both are equal. If you represent anything, so this value is so 61.4. This value is 23.9. So what is that value? No need, because if you just observe it, 61.4 is the maximum value. So maximum bending moment it reaches at supports. We already got it. So at that supports, we have to maintain the higher depth or higher width. The cross section of the section should be it will resist the 61.4 moment. That is our criteria in next RCC. So in total structure analysis, we have to find out how the applied loading is distributed among the beams, among the structure. That is the course objective. Okay. The total course objective is if the sum of the load is placing on the structure, how it will distribute. how it is distributed. So if you know the it where the moment is getting maximum or minimum, at where what is the moment, we have to provide the cross section to resist that moment. That is going to be teaching in RCC next year. Okay, one line total R's, total structure analysis. Okay, that's it. So that's it now. So that is the value. So otherwise if you take in shear force diagram also, that's it. That's it. Most probably shear force at B is maximum. Maximum is it will take higher value. It will take higher value. Mostly it will take this value. It will come to like this, and will come like this, and will come like this. It will come. This is a shear force diagram. Most probably you will get the value. What is that value? So this value both are equal because symmetry na? This value also equal. Okay, this value also is equal. So most probably this is the shear force diagram. Shear force diagram. Okay, understood? That is the shear force diagram. That is the bending moment diagram. You can write deflection diagram also. You can write deflection diagram also. How it is deflect? Because if you see it is B is intermediate support and it uniformly distributed loading among those two spans, and it is symmetrical. It is symmetrical means what? The deflection, the rotation at B is 0, because the loading at this AB span and BC span also same equally distributed. If you see it is, if it is equally supported, how will it deflect? It will deflect like this na? So there is no rotation at B because exactly it is in center. If it is something, if you see it is, if it is there, if it is something load is there, most probably it will deflect like this because it has a loading, there is no loading it. So most probably if it sees, if loading is there, it will deflect like this because it has load. But equally distributed load means what? Most probably there is no support, there is no deformation at B joint. So okay, so that's why if you see it is, so point of curvatures are there, these four locations. Based on that you can draw, and it's 0, making zero slope, and same thing rotation, and will reach it. Otherwise, to maintain, I am not a good artist. To so many of good artists are there in our class. Try to draw. So see it is this not too much deflection. The deflection you can't see. Okay. No need to feel that it has some large deflection. See your top roofs. It has the deflections. See your columns or see your beams. Or just on your top of your head. They have the deflections, but you can't observe that much low, and also rotations are also very small based on the loading and between those two opposite sides, two adjacent sides. Okay, that's the problem, end of the problem. Okay, now you can solve how many, any stores, any type of loading. Okay, I will give one assignment. Can you do it? Very simple assignment, no problem at all. No problem at all. So this is a problem. You can solve it. This is 2 kilonewtons. This is 1.8. This is 1.8. And what loading I have to given? Which type of load I want to given? I will given the loading of simply supported and fixed beam. We already solved, no? We already solved difficult problem. Why are you giving very easy problem to you? Can you solve the problems? Okay, no need. Take any type of loading. So if it is easy na, just type directly one equation. So I will change it. I will change like giving fixed support here, fixed support here, hinged here, and I will give which type of loading. So I will give this type of loading. So again it's a 2 kilonewtons, 2 and 2. So 1.8 1.8 now, so 3.6 divided by 3 is 1.2. So I will give 1.2 1.2 1.2. Can you solve it? So I will just change the loading. So if whatever the loading I will give, you can easily solve it. Not only uniformly distributed load, point loads, eccentric load, you can also solve with respect to the uniformly varying load also. No problem. Can you face any problem? No. If I give uniformly varying load, the bending moment diagram. So that is a 3. So what is that bending moment diagram? So bending moment diagram, it's not a parabolic. It's a, what is that? Cubic parabola. So what is the area of the cubic parabola? What is the area of the cubic parabola? Where is the centroidal of the cubic parabola? Are understood? If I giving a varying load, you have to get a cubic parabolic shape of bending moment diagram. Cubic parabolic. So what is the area? And where it is the centroidal distance from this location to this location? Just find out, and just this, maybe you can replace the problem. Just take loading and you can take a parabolic uniformly distributed 2 kilonewton per meter. 2 kilonewton per meter. Okay, solve it. Try to solve it. No need to say, no need to explain, because just there is no, the problem you facing only with what is the area of that parabola, what is that area of the parabola, what is the central distance from each location. That is the only area you may be facing the problem. So try to search in mathematics and find out and solve the problem. Okay, that is your assignment. That's it, na? That's it. Tomorrow we will explain, if the one of the support is sinking, any support is sinking, how to we will solve. We already solved the problems in fixed beams. If any support is sinking, indirect loadings are generated. So in a continuous beam, one of the support is sinking. How we will solve the problems? Tomorrow we will see. That's it. That is the today episode.